Well, it wasn't until over 50 years later that something else was discovered that also gave out this light, but without such high temperatures. This was actually discovered accidentally. So a chemist was heating up a mixture of solutions and it boiled over onto his gauze, okay, and it started to glow in the Bunsen flame. And we use this nowadays in light mantles here. So this is a camping light. We have a source of gas here, butane. This burns and it plays on the mantle at the top of the lamp. So this is the white element that we see at the top there. And this is composed of some rather rare elements. We have oxides of magnesium, lanthanum, yttrium, and zirconium. Okay, well, let's see if we can get one of these to work. I've got a mantle here. So here is the mantle from one of these lamps. And just with my Bunsen flame, well, first of all, let's just try and heat up the gauze. So my Bunsen burner can get things red hot. So a metal or something like this glows, but it only glows red hot. There's not really very much light coming out of that. But these oxides, these particular compounds, when heated, give out a really, really brilliant white light here. So this is much better at converting the heat energy into light. But only certain compounds will do this. So let's see if we can find these on our periodic table then. So where are we? We have yttrium. We find yttrium. Very good. Yttrium's the Y. Zirconium. That's quite easy. That's the one next to it. Lanthanum. Very good. Down here. After a while, it was found there was another element that worked even better than these ones, and this was used for quite a long time, and this element was thorium. Can you perhaps find thorium for me, please? That's down the bottom there. Very good. So there's thorium. But thorium is just 2 spaces away in the periodic table from uranium. Okay, here is uranium. Okay, so thorium, like uranium, is also slightly radioactive. Well, I have here an original mantle, one of the early types. It's still in its little plastic bag. We bought this fairly recently. The one that we have in the lamp is actually a modern one, made of these other elements, yttrium, zirconium, and so on. But this one does, in fact, contain thorium. And we should be able to see that this is radioactive. Now, I need to just get down here so you can hear the clicks from the Geiger counter. So even though it's still in its packet here, you can hear that it is rather radioactive. So I'll put that one back in my radiation-proof box, I think. There we are. So we no longer use thorium, even though it's actually the best at converting heat into light, better than any other oxide. Okay? Thorium oxide actually has the highest melting point of all of the oxides and is very good for converting heat to light, but I say it's abandoned now because it's radioactive.